We make quite a bit of use of DeMorgan's laws, so I thought I would take the time to actually verify them, not only because we use them so much, but also because it's a good exercise in emphasizing what it means for two statements to be equivalent. In any case, I want to verify both of DeMorgan's laws, and I'll start off with the first one that tells me how to negate an or. So I'm going to do this one first. This is the first one of those. Now, as usual, I'm going to create a truth table and list all possible values. But remember, when I'm saying two things are equivalent, that means if I take this expression on the left and do the truth table for it, and then I take the expression on the right and do the truth table for it, the truth values will be identical. So I'm going to create a truth table, but I'm sort of going to build it into two pieces so that it's easier to see the equivalence. So I'm going to take every possible value of P and Q, as I usually do, true, 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 false, false, true, and false, false. And then normally I have a column for what I'm trying to get the truth value for. But so what I'm going to do is I'm actually going to create a big column and split it. And in this part here, I'm going to do the truth value for the expression, the statement on the left of the equivalent symbol, and on this part over here I'm going to do the truth values for the expression on the right. And if these two sets of column values come out identical, then I have shown that those two expressions are equivalent. So that's the game I'm playing here. So to get started, I'll work on this one first. On the first row, I'm going to put a T in for P and a T in for Q, and I'm working on the left. So that becomes the negation of T or T. And I'll move down as I usually do. Now I'm going to put a T in for P and an F in for Q. So that's the negation of. And as a matter of fact, once you see such a pattern here, if you want to, so you don't accidentally forget it later, you can go ahead and fill in what it's going to look like. Every one of these is going to look like that. Now I'm putting in a T for P and an F for Q, so that becomes T or F. Down here I'm putting an F in for P, so that becomes F or, and I'm putting a T in for Q, so that becomes a T. And here I'm putting an F in for both, so I get F or F. Now let's go ahead and get this simplified, this left part. So that's equivalent to, as I simplify, true or true. Remember the truth table for an or, it's only true, excuse me, it's only false if they're both false for an or. Well, they're not both false, so that's going to be true. But remember, there's a negation out in front of every one of those. And again, if you want to make sure you don't forget it, you might just go ahead and write it in before you even get started. So anyway, that negation is there for every one of those. True or true. With an or, it's only false if they're both false. That means that's going to be true. It's only false if it's both false and they're not, so that's true. It's only false if they're both false and it's not, so that would also be true. They're only false if they're both false and they are both false, so that would be a false. And finally, not true is false. Not true is false. Not true is false. Not false is true. So if you just ignore the preliminary work, I have computed the truth table for the negation of P or Q. Now I want to forget that for a minute and do the negation of the do the expression on the right hand side of the equivalence. So I'll start back over with both P and Q being true, but this time I'm trying to get the truth values for this expression. So that would be not true and not true. As I move down, I see I'm going to have a not everywhere and I'm going to have an and in the middle. So in the interest of trying to avoid mistakes, one of the things you can do is go ahead and extend your pattern down the column. I think you're less likely to make an error if you do that, because I see I'm going to have a not in front of all the P's, I'm going to have a not in front of all the Q's, and I'm going to have ands all the way down. So in this, now I'm down to the second row, and in the second row, P is true and Q is false. So P is true and Q is false. In the third row, P is false and Q is true. So P is false and Q is true. And lastly, in the fourth row, they're both false. So be false and false. Now keep moving along. Simplifying. Not true is false and not true is false. So I get false and false. Not true is false and again, if you want to extend that pattern down, not false is true. Not false is true. Not true is false. Not false is true. Not false is true. And finally, we're doing an and. Remember, with an and, it's only true if they're both true. Well, the only place where they're both true is here, so I can go ahead and put a true there. They're not both true anywhere else, so that must mean everything else is false. Now, amid all this clutter, you may not see what you have here, so I'll do what I normally do. I rewrite it so that you can actually see it without all the clutter in it. So I'll get rid of all this preliminary work here and just write down what I got in this column, and that was FFFT. And same thing over here. I'll get rid of all the clutter and just write down the final result, FFFT. Now that you've got the clutter away, you can see what you were going for. To be equivalent, the truth values of the expression on the left side of the equivalence and the truth values for the expressions on the right side of the equivalence have to be exactly the same. If this is F, this has got to be an F. If this is an F, it's got to be an F. And you look down, they're identical. And that verifies the first one of DeMorgan's law. The fact that the truth values are identical. Now let's do the same thing for the second one. The second one of DeMorgan's laws remember, going back to the beginning, the second one we now need to verify. And I play exactly the same game. So I start off with my truth table with every possible value of P and Q. And I take my, again, just a shortcut to make it easier to see what I'm doing. I divide that last column into two pieces, and on the left I'm going to do the truth value of the left side of the equivalence, and on the right, the last column, I'm going to evaluate the truth value for the statement on the right side of the equivalence, just as I did before. So I start off again with the first row, and I'm going to do this column first, so I'm working here. So I put T in for both. So I've got the negation of T and T. And I'll work down. Here I'm letting P be true and Q be false, and you can see that every one of these is going to have a negation, so I'll go ahead and write the pattern in so I don't get distracted later and leave it out. And also see that there's going to be an and all the way down. Okay, oops, not an A, that's an and. So in the second row, I let P be true and Q be false. So it would be true, false. In the third one, I let P be false and Q be true. So P is false, Q is true. So it'd be F, T. And the last one, they're both going to be false. It'd be false, false. Moving along as usual. I'm going to notice the pattern. There's going to be a negation everywhere, so I'll go ahead and put it down. And then I'm doing an AND. Now remember, with the truth table for an AND is only true if they're both true. We're looking through here, the only place they're both true is here, so that's going to be a true. They're not both trues anywhere else, so the rest of these will be false. Keep in mind, however, that you still have a negation in front of those. So one more step. The negation of true is false. The negation of false is true. Negation of false is true. The negation of false is true. Now I've done my truth values for the left-hand side of the equivalence. I'll start over and I'll do the same thing on the right. So now I'm going to let P and Q both be true, but I'm going with this expression now, this statement. So that's the negation of true or the negation of true. And notice the pattern. There's going to be a negation and an or and a negation. A negation and an or and a negation. A negation and an or and a negation. That way I can just focus on the values of P and Q. I know everything else is going to stay the same. So this time P is true and Q is false. So P is true, Q is false. The third one, P is false and Q is true. P is false and Q is true. And in the last one they're both false. So I get false, false. Okay. Now keep moving along. Not true is false, and I see that there's going to be an or all the way down, so I'll go ahead and put that down there. Not true is also false. Not true is false. Not false is true. Not false is true. Not true is false. Not false is true. Not false is true. And one more time should do it. We're doing an or. With an or, it's only false if they're both false. And if you look down through here, there's only one place where they're both false, and that's this very first spot. They're not both false anywhere else, so the rest of them will be true. Finally, as I've done before, I want to get rid of some of the clutter. It was very nice to be able to put my preliminary work right into the table. I think you're a lot less likely to make a mistake if you do it that way. However, once you've gotten it done, it's probably better to get rid of the clutter. So now I'll take out all my preliminary work and just look at the final results. Over here I've got F, T, T, T. Over here I have F, T, T, T. And as before, the only way two statements are equivalent is that their truth values are exactly the same. So these are identical to these row by row. False, false, true, 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 true. And that's what you need to verify equivalence. So the second one is verified. By this procedure. So this procedure verifies the second one. So now I have completely derived both of DeMorgan's laws. And again, the reason I know that I verified it is my truth values match up row by row.